Okay, I think I'm ready to get started. Okay, so let's build the latest version of the game. So open the debugger. Okay, so this is the game. It's a turn-based strategy game, and I am building out the prototype right now. And we have this level that I'm working on. Um, Last stream, I fixed a bug in the design. So now entities have these bounding boxes so that when they're not in an alert state, um, they wander around the level. But they no longer just wander wherever they please. They have to stay within that box, which is very helpful from a level design perspective. So, um, one of the things I want to look at today is I saw a bug where an entity for some reason was able to go into this square. Um, and I want to see if I can reproduce the bug and find out what the heck's going on. So first of all, let's see here. This square is... I don't have blocking turned on. I used to have something in here which told me whether a tile was blocking or not. So let's add that back in. So let's see. This is in the debug overlay. Let's see. Want a mouse tile position. Okay, so we want to add a new thing, which is like, we want to write tile blocks. And it's just going to be true or false. Right? Is tile blocked? And that needs the entity manager. Oops. Entity manager. The current game map. Oops. Position map. Actually, this. Okay, so what's next? And then, so we need the input.mouse.position. Okay. Okay, that should be all we need. Save, build. Back over here. Run. Okay, so blocks true. Okay. Ooh. Why am I getting such wild variance in the frame rate? And we'll figure that out later. Pile blocks true. That's bad. Just always true. Why would that be? Did I screw something up? Is tile blocked? Buffer, is tile blocked? Oh, whoops. I need the mouse tile position. Right. Yep. I screwed that up. Mouse tile position. Alright. Okay. Alright, so I have this thing, this tile is blocked, and this tile is not blocked. Well, that would explain it. So why isn't that blocking? Let's go over to our tile definition. And it's this one right here. So I believe that last parameter is the whether or not it blocks. Yeah, okay. So we just forgot to set this as blocking, so true. That was it. Easy win right off the bat, which is nice. Alright, win the game. So now that is blocking. Awesome. So let's try to run through this level, because last night I tried to run through this level as I was playing it normally, and that bug came up. So let's try to do that again. So the concept of this level is essentially I'm trying to guide the player into the idea of environmental interactivity. So you come over to the shrine and you get a spell, and that spell allows you to push things. And you're like, oh, there's a door there that I want to get to, but I can't because these boulders are in the way. And so I'm going to push them out of the way, right? And I come over here, and these enemies see me, right? It's like, well, maybe I should try to use the new spell that I just learned on the enemy. And that went through the wall. Oh, you know what? You know what happened there? So this tile right here, can you see that on the, oh yeah, so where my mouse is, this tile right here is not blocking, and this tile isn't either, because this wall right here is, this wall is a doorway, so that wall is, technically speaking, it's not on this tile, it's on this tile, and so that means there's a diagonal to which the enemy could have gone through. So this is just like a broader bug of doorways. You should only be able to move through them in one direction, essentially this way. You shouldn't be able to do diagonal movement through a door, right? So I need to make a note of that, because I'm not quite sure I'm going to fix that right now, and so I'm just going to put that in the to-do. So we did that. In the to-do, we did that one too. Awesome. We need to bug doorways allow movement through that. And then play. Okay, and then we'll tackle that later. Okay, so back to the game. So we were trying to go through. So let's try pushing you. So the idea is like, oh, I can push him into the wall and kill him because of the kinetic force. And why were you able to come? Oh no, that's the entity from earlier that I pushed through the door. That's right. Okay, yeah. So push him in the wall and kill him. You know what? I should make that faster. Okay. Pushback movement DT. Let's make that 2. Just to get across what's happening there. Okay, so we got this entity. So he sees me. And this is where it's going to introduce to the player the idea that, oh, you can actually push things into other things, and then they both go flying. So that worked. That's cool. And then we come up here. Okay. So that's all working great. Okay. So one of the concepts that I had for this large area over here is the idea that we could have, like, this would sort of be, this is again just sort of stretching what a level could be in this game. I'm trying to figure that out, right, through playing with the ideas. One of the ideas that I had for this room is sort of like a, I guess you could call it like a chapel layout, or like a something like that. And the idea would be like, hey, you got these big benches through the whole level, like the pews in a church. And what if it'd be really fun if, like, you were to do it like dominoes, where you like threw one of the back pews forward, and it just like threw all of the pews that were in the level forward, sort of like dominoes, and you could like crush all the enemies at once. That'd be kind of fun. Because wanton destruction in a game is always fun. But in order to do that, I need the concept of an entity that spans multiple tiles. So right now, an entity can only be on a single tile. And the other problem that we have is, let me reload the level. The other problem that we have is there's this bug in how the FOV system works. So I'm going to do, what was the command again? It was, what's the commands? FOV. So FOV. So now you can see on the ground what's happening there. Whatever, it's not important. You can see that this FOV is coming through the wall. Yeah, I see here, right here. It's just going straight through that wall. So if I were to step there, he sees me, despite the fact that it's straight through a wall. You know what? I'm going to go back to the debug FOV code. Toggle FOV debugging. And because it's kind of hard to see, right? Blend color. I'm going to bump this up to like 8. So let's do that. And run the game. Then there. That's much easier to see. Okay. So red denotes that the tile is blocked. So can we... Oh. Okay. Did I just... For debugging purposes, I think I kind of want to move... So in the level editor, I can turn off a layer so I can see what the hell's going on. I think I kind of want to move that, allow that to... I think I want to allow that to move into the gameplay code, because right now we're resetting that when we exit the level editor. So I want to go to, where is that? Here. Current game state. I think what we're doing is we're just setting that all back to 0. So can I, like, because this data, that's saved on the map, right? Whether or not a layer is visible. Layer visible, yeah. Close these. Okay, so layer visible. So I just want to save that. So auto saved layer visible equals game state dot game map dot layer visible, and then gonna come down here and just do this. Okay. Just make a note for myself. This is for debugging, so we can see so we can turn off layers in gameplay. Okay. Okay, so back to the game. Go over here, come up here, turn this off, go back. Hey, look at that. So the walls are still there, we just can't see them. So now I want to turn on FOV debugging. And so this is where the walls are. And so despite the fact that these walls are blocking, if I come up here, yeah, so this guy is just seeing straight through that wall. Which is annoying. This is going to take a little bit of research because I didn't actually write the code for this. I translated it from its original thing, but I didn't write the algorithm for the FOV stuff. So this is going to take some grunt work. So let's grab this. So I think a resource that I used in the past was FOV. Let's make this bigger. What's the difference between ray casting and shadow casting? So I'm thinking what I'm thinking is just using one of these C libraries. And just doing a little bit of research on the differences between each of these approaches. Okay, ray casting is a method for calculating field of vision where rays are traced. So essentially, it's just going to be like a vector through the level. Rays are traced from the center of a source square to a select number of destination squares. So squares are marked visible as the rays pass through them, and walls will block the rays. Cast every the method about the shadow cast. Every square along the perimeter easy to implement. Yeah, okay. So I think the thing I translated, if we go to the FOV code right now, I'm using this thing called recursive FOV. So I wonder what... Let me pull up the original JavaScript code, because that was what I translated it from. I think this was it. And then, what.js? Recursive shadow casting. Recursive shadow casting algorithm. Implementation. FOV using recursive shadow casting. Okay. So that's... there. Okay. So this is the algorithm that we're using right now. A working field of view algorithm is one of the easiest. It was... There can be seen the simplest approach is to trace lines. So this is the ray casting approach. So the problem with this approach is that many map cells are visited multiple times, most often near the starting point. So you do a lot of unnecessary calculation. There are a few things that can improve the performance. The most obvious can be made. Use a simple calculation, I'll raise the column. Shadow casting defines FOV calculation into 8 octants and visits the map cells in a totally different way from normal raycasting. Instead of tracing lines from the center out to the edges, shadow casting visits map cells row by row or column by column, starting with the nearest row and working its way outward. I'm not quite sure what this is supposed to be showing me. Was there supposed to be like an example map? Okay, it calculates what other cells in rows, columns farther away. Divides the field of view to 8 octants. Okay, that makes sense. This all seems pretty complex. I don't know. That doesn't seem like... It's just on first blush, it seems like we're overcomplicating things. So... what is this? MIT license. Let's see if this is on GitHub. So this is just a backup, right? Yeah, these are all backups. There's another one. Library permissive field of view. What's permissive field of view? Okay, permissive field of view defines more loosely. A destination square is visible from a source square if there is any unobstructed line to some point in the destination square. So this is like raycasting again? It means the players automatically peek around corners. I don't like that. Most complicated method to understand and implement. Well, that's probably not a good thing. I want to go with something that's really, really simple. To be honest. So let's go back to shadow casting. What's this? What's it written in? C. Interesting. What's the license? BSD. Okay. The simplest one. Oh, so it's actually the C++ part are just language bindings. Okay, that's good. Ooh, it also has a pathfinding implementation. That's good, because my A-star implementation sucks. Like, it's really slow. So, let's take a look at this. Pretty popular. Function tools and other resources. What the? CMake, you will be the death of me. Dude, what? Documentation. Oh, this must be because they have all the windowing stuff and everything. Well, that sucks. That makes something that should be very simple very complicated. Okay. Excuse me. Oh man. Okay. So what I'm thinking right now is I'm thinking this sounds pretty darn useful. And I probably what the reason we probably have that bug in the FOV thing is because I probably made a mistake when I was converting the JavaScript code to D. So I'm thinking I might just want to try to port this because it's a lot more direct translation from C to D. So let me take a look at. So let's take a look at their A-star code. Where's the A-star code? Would it be under like pathfinding, perhaps? Pathfinding, yeah. Looks like they're using their own custom array type. Is there any documentation? I guess no, use one of the command lines when I was getting started. Documentation is here. Okay. Dijkstra. This is not very good documentation. Gotta say. I don't know, man. I could just have like a freaking function called A star. I don't understand why this is. So is anything up here? No. I don't know. Maybe there's better documentation on this somewhere else. So lib t cod A star. Yeah, so this one just has a frickin' thing just called A star. So if I go back to here, to be in path, I guess. Nothing. Oh boy. Oh. I don't understand why it's so hard to just write a single line of dialogue. Literally just one line that says, this is how you call the A star thing. That's it. That's all you need. I don't get it, man. I just don't get it. Like, if it's this poorly documented, I don't know if I want to think about using this. I'm thinking about going back to this. You know what? This is a automatically exported from Google Code. Okay, so I guess, what is M4? Isn't that a build tool? So I guess this is the source. Hey, just look at that. Look at that. That's all you need. It doesn't need to be complicated, people. Well, maybe back in Logitech COD. What, FOV maybe? Here. This looks pretty straightforward, actually. The A-star stuff, not so much. Oh. So we have all these different... Okay, so if I... Hey, look! This is actually documented! How about that? Oh, they want you to use their frickin' map structure. Not a big fan of that. Not a huge fan. What's going on over here, though? So what's the API? Set all the default... Create new settings. Uh, yeah, it's fine by me. Not implemented yet. So that's whether... Ah, I see the problem. Right, so this is just like an ASCII definition. So like, this would be the player, right? And they would be right next to a wall. And the idea is like, all of these tiles here wouldn't be visible if you can peek around corners. I wonder what the default, because this says isn't actually implemented. I wonder what the default behavior is here. Whether to call. So this is just setting stuff. Calculate a full circle FOV. So you got your settings, you got a map pointer to the map data structure, X coordinate and a Y coordinate, and then a max radius. So are these void pointers then passed to a callback? Is that the idea? So this is the function that we want. So find X positive. So it's doing the octant thing too. Okay. Okay, so it's like, I guess my question is, macros. Macros. Octant. Bug printing. Big settings. Apply. Aha. Interesting. So there's some sort of... Aha. Yes. Okay, so this is what I was looking for. So this is setting the callback. So it's a bool, and you get a void pointer to your map thing. And then this is whether or not it's see-through. And then you also get a... okay, I actually like this API. This is a well, I'm going to hold off on saying that for now. This is a better designed API than the previous one. Because it doesn't freaking assume your Mac data structure. libtcod seems like it's more just like all-encompassing. Rather than trying to be a helpful API. It seems like it's trying to be like a video game engine of some kind. Hey, zero dropped frames. Frickin' Comcast is finally doing its job today. How about that? It's a good thing I pay them thousands of dollars a year. Take apply. So, problem is, so this is advertised on Rogue Basin, which I believe is a pretty reputable source. I've used them for algorithm stuff discussions before, but I have no idea what the quality, because like, okay, here's the problem. Like, I don't have a prototype C thing that I can use to test whether or not this algorithm that they're using is actually like bug free, right? is actually going to... Should I make a simple... Because here's a problem. I don't want to convert this to D without knowing whether or not this is actually going to be helpful. But making some sort of C prototype would also be pretty difficult, maybe? I could make something that just prints the console. I don't know. I think what I'm going to do is I'm just going to take the risk, and I'm going to convert this to D. And we'll see if that solves our FOV problems. Okay, I'm going to get started on that. So we're going to create a new folder over here. We're going to close this for now. Oops. Did that? I hate that about this program. I hate it, I hate it, I hate it. Anyway. Close this. Okay, so we want to create a new folder over here. Which is going to be like, new folder, lib FOV, right? And it's going to have, how is this formatted? It's like source and then the name of the thing as a folder, right? So it's like new folder, source, and then new folder, lib FOV, and then we need a new file, package.d. And then back over here. Pretty sure this was MIT licensed. Yeah, so I'm just going to copy this. Go back up here. And... Oops. What the... Thanks. So what is this map showing us? Dude. I can't interpret this. The other map was easy to understand. I have no idea what it's trying to show me here. Whatever. So I'm gonna need this. It's gonna be in file scope. Gonna need this. Find unit. Replace. Place. You know what? We'll do that later. I'm thinking about how to translate the macros. You know what? I'm just going to translate this to, because for now, I'm just going to translate this to demixins because it's easier. But I'm hesitant to do that a little bit because I don't want to rely on demixins too much. Because I think I'm going to have to remove them eventually. What did I copy to? So we've got FOV slope. Here. Okay. So we got this to... So I want this. Copy. Okay. You know what? I need some more coffee. So I am going to be right back. I'm going to take a 5-minute break. Okay. Now I have to keep one headphone off because I know at some point she's going to want to be let back in. Okay. Okay. All right, where were we? So okay, yeah, I was gonna translate this macro. Okay, so I already did something similar like this. Push. Gosh. Where is it? Here it is. There. Okay. So it's like this. So we need... And these need types. So sign... Where's this? My CPU processor is a little rusty. I bet, if I remember correctly, this means it's simply a string replace. Let's see if that makes sense. So this is 1, 2, 3, 4, 5. What does P in this case mean? Okay, yeah. Okay, so that, yes, that makes sense. Okay, so we got a thing which is going to be, so we need to copy this parameter list. So this is going to be a string. This is going to be a string. This is going to be a string. And this is going to be a string. And then RX, on the other hand, that's a string as well. Okay. So string. So NF. What are you doing? And that's also a string. Wait, where's this coming from then? Oh, that's in the. Okay, I see. So this R. What? It's assigning RY. Hang on. You know what would actually be useful? I'm going to come back to here. And I am going to download this code. Is this still up? Hey, it is. Oh, the dog wants to be let back in. Yeah. Okay. So anyway, getting back into it. Is there any documentation on building this? Just gotta make file. How complicated is the make file? Oh. Oh, why you do this to me? There's no need for that. It's just a single file, man. Goodness gracious me. Okay, so here's what we're gonna do. Goodness gracious. This is one of the things I just absolutely despise about C and C++. Make files just need to get out of town. How did I... Okay, here's what we're going to do. I'm going to download this. Download as zip. Save. To the downloads. Show in folder. Extract. And then what I'm going to do is I'm going to bring this up. And we are actually going to go into there. So, users, me, downloads, lib, FOV master. Okay. I'm pretty sure the command was something like, okay, so hold on. MSVC pre, output. Pretty sure this is what I want. File, yes. Yes. Okay, so essentially what this command is going to do is it's going to just take the C file and it's going to spit something out, which is the result of the preprocessor, but it's just a C file. It's not going to compile it. So if I do CL, and that's in the, okay, it's in the path. So CL dash, and that this preserves comments. So /p/c. What's the layout of this? So FOV FOV.c. So FOV.I. Open with code. The hell is all this? Oh, whoops. No, wait, what? What the hell is all this? This is inserted by Microsoft. Crap. Okay. Oh my gosh. Where's the thing that I actually want? Okay, we need FOV octant. That's what we're gonna look for. Hey, look at this. So it's recursive, I suppose? And it's all on one line. Oh man, that's so cool. That's amazing. Okay, do we have like a C formatter online? Online C formatter. I mean, that's better, but you know. Okay, so copy. Dog, what you doing? Okay. Copy this. And this is going to be our sort of reference material. So essentially what we just did is I went in and just did the macro expansion for this for one of the functions so I could see what the hell was going on. Because the preprocessor language is not, I don't know, it's not very readable and understandable, and I don't like it very much. Okay. So the thing I was confused about was this line right here. So data source. Why is there spaces? What? So this is the definition for PPN. So down here in PPN, RX, RY. I guess that's just a string replace because that this is an X here, and dude, I don't understand this spacing crap that like this is literally the output that the compiler preprocessor sends to the compiler. Why the hell is there such? Every byte is a wasted byte. Whatever. Whatever. So we're just going to delete all this for now. And I'm just going to say, I'm going to copy all this. Yeah, this shit needs to go. Grunt work, oh, this is just grunt work. Stuff that I have to do in order to make the gameplay fun, but it's not a very fun thing to program. That is the life of a programmer. Sometimes things you work on aren't that fun. Oops. Okay. So now we have the function definition here. So the next step is, so it's NX, NY, NF. And so that comes to PPN. So FOV octant PPN. So that would be string, string, string. So essentially what we're just going to do is what we did over here, which is just, so NX. NY. NF. Whoops. Okay, so, and then we delete this part. Bam. So it's the same thing here. We just say copy. We're replacing this with RX. We do the same thing here. This is RY. And here. And this is RY. Right? Okay. So I don't think... Oh, there's... So this is recursive, eh? I see. Okay, so we just do that. Right? So it's up here. FOV octant PPN. Yep, that's... Okay, so this is a cast. This is a cast. This is a cast. This is a cast. Replace uint. Place. Cast. 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 Save. Okay. Okay, so unit diagonal, height, dx. Okay, no, that's one of the parameters. Okay. Okay. Ry. So Ry. And then this function definition again. And then again. Okay, I don't see anything else obvious, so we're just going to comment this out. YouTube. Okay. And then what did we do over here? So this, yeah, so mix in and that. So bum 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 bum. Mix in. Okay, so this is string. Oh my gosh. I don't know, just readability, just... I don't understand. Some programmers... Terseness is not the end-all, be-all. H... Okay. So... where... Apply edge. So that's in the... Where's this line? Click apply. Settings apply edge 1. So that's just a constant, eh? Right? If I come down here. True. Okay. So these are strings too. String. String. Okay. So we're just going to do this. We're going to say replace apply edge with, so replace. Do the same thing with apply diagonal. Replace, and I guess that's the only one. Yep. Okay. So replace this with this. Replace. No. Replace. Replace. Same thing with Y. Replace. Okay, and then N. And then, oops. Place, M. Okay, and then true. Bum, 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 and then false. Okay, cool. Okay, so that actually should, ooh. Oh no, wait, that's correct. Okay, so this should actually compile. So let's, well, not actually, because we have to do, well, let's do, let's add it to the build system. So we are going to come up here, and we're going to add a new library, and this is, add a new library. This is going to be lib FOV, lib packages and FOV source. There is no dependency here. It does not need a version. Add source file lib FOV, but this has a dependency on the game. So if we try to compile it, we should get an error. Or we need to go back to the yep. So first, we just need to do a find and replace. I'm just going to delete this. So we're going to do a find and replace on arrow and change it to dot notation. That's step 1. Step 2 is replacing C-style casts with D-style casts. So cast. Replace. And then replace, 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 replace. No, no, no. Okay, so float. Replace, 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 replace. No, 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 no. Wait. Yes, yes. Yes. Cast, 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 cast. Okay, and then you need to do the same thing with int. Int. Replace, replace, replace. Oops. Okay, so what's the problem here? Why are you complaining? Never modified. Oh, this whole thing needs to go. Okay. Not modified. So size T. What's the problem? Ah. So everything in here is going to be at no BC, no throw, then pointer. Alright, what else is the problem? Fit line 56. Undeclared identifier FOV settings type. Yes. Okay, so that's the next part. Here we are. Struct. Where was the original file? Where did the C file go? Here we are. This is the H. No. There. Okay. No. Okay. FOV H. Need this. Here. Okay. So copy this. The settings type, settings pointer. Okay, so this is a function pointer. And this is the, trying to remember the syntax here. We're just going to clean this up. We're going to say this is a, is opaque function I why okay, sorry about that. There's spam in the chat. Okay. Okay, so is opaque function equals. It is a function, and it is going to be a bool returning function, which takes a void pointer and into x and y. And so this is it's called opaque. And then we need a set lit function, which is going to be a void returning function. And it's going to take these parameters. And it is going to be called apply. Actually, you know what? Since these are types, I'm going to do this. Okay? So we have that. FOV shape. It's an enum. We need to get all of these enums. Actually, these need to be public. So these are going to be bare enums. So this would be decimals. And then 1, 2, 3, 4, 5, 6, 7. Okay, and then this is going to be an enum class. And then it's also going to be an enum class. And this is going to be an enum class as well. Okay. So we need this type. Oh, and we need to replace this with uint. We need this alias. What is this? This is an unsigned pointer? I don't understand why you need just to say it's an unsigned pointer. Very bizarre. Wait. Huh? Oh, no. Get rid of this. So, ugh. Okay. So, what's left? Found sign X when expecting. Right. Unbelievable. Okay. Come on, man. Where was that freaking thing again? So, okay, get rid of all the crap that we don't need right now. Okay, so this data source. Oh. Okay, no, that's fine. Here. This is what this expands to. Right? Data source X. Pointer source X. Plus. Ah. I see. Yes, it's a parameter. Okay. So we need another thing here, which is bam, and then so we need sin X, sin Y. Sin X, sin Y. Get rid of this. So where else does sin X appear? Nowhere. Where else does sin Y appear? right there. Okay. Run. Deprecation used for an empty statement. Line 211. Ah. Go lay down, dog. Dog, go lay down. Go lay down. Holly, go lay down. Good girl. Good girl. Want a toy? What do you got? You want a toy? You're a good girl. Okay. Okay, so we have this. Alright, we need a player replace all the nulls with null. Place. And then we have to say okay, so we need to import core.stdc.stdlib. And then stdmath. What else? Cannot modify undeclared identifier FOV shape circle recalculate. Okay, with okay. What else? Mem copy, so that's instead string. There. F this. Where is that coming from? Nothing. Nothing. What is this? Okay. So we just need float? Yeah. Casing is important. And then we want to find this. Okay. Cannot modify string literal. Where? Ah, I see. Hey, look at that. It's building. Okay, we're making progress. Making progress. Okay. Back over here. Here. Where'd it go? Here we are. slope. Okay. So you have slope, and then we have this macro, and then we have, okay, so we need to copy this now. This is now the, oh, more macros. Oh, my favorite ever. Just grab this, then come back over here. So this is private. This is private too. We just grab this, and then okay. Okay. Then back up here. That all looks good. So we need to now translate these macros. And I think that's it. That's the last thing to do. So let's copy this. Good girl. Okay. So we need another mix-in template. And this time it's going to be beam direction. And we're going to take all of these. And we are going to say, we're just going to assume that all of these are string values, because they probably are. String. We're going to copy this. We're going to get rid of these. Place. Okay. Then we are going to define this as a mix-in. Boom. Bump, and then okay. You start replacing. So H something 1 D boom. So P1 P2, only one of each of those, and then P3, and P4, P5, 6, oops, 6, 7, 8. So 5, 6, 7, 8. Okay, I think that's all we need to do there. So that's the beam direction macro translated. And then, so let's copy this again. And then, so we need beam direction diagonal. And DP1, 2, 3, 4, 5, 6, 7, 8. So that's the same parameters. We just need to copy this and paste it here. And get rid of this. And then we change these to be mix-ins, right? And then Cool. So, bum, 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 bum. Okay, so same sort of idea, doing this, and then replace this with nothing, nothing. Whoops. Okay. And then same sort of idea here. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. So, what else? I think that's all we need to do there. Let's see if this compiles. Place with uint. Okay, what else? FOV direction type. Declared identifier. I'm just gonna make this an integer. Then I'm just gonna make sure that all of these are integers by explicitly defining it. So I believe the syntax is this. Isn't that the syntax? No. Well, it should just be integers, so that should be fine. PNN. 406. G406. Ah, these all need to be strings. I see. I'll replace this with this. String. String. Place bum bum. Same thing here, same thing here. Dun. Shump. Shump. Is that everything? Mixed in. Does not match template declaration. Yeah, let's just make these strings too. Okay. 330. Direction equals. Declaration expected, not if. Huh? What do you mean? Declaration expected, not if. Can we print this out? So, pragma message. Mixin templates are not regular templates. While evaluating... Oh, come on, man. You gotta be kidding me. Okay, I'm pretty sure there's a DMD help flag. Let's see. Debug. Extern. Generate. Map mixin. Expand and save mixins. Aha. That's what I want. So back in the build script. We want to set the DMD flags, which are defined here. So, then we need a file name, right? Expand and save mixins to a file. Okay, so mixin, let's just say mixin pass.d. Save. Okay. Run. Oh, we need to get rid of this. Let's try it again. So, did that work? Hey, look at that. Did we get... So we want the expansion at line 406. Because it errored out, I suppose? I guess? I don't understand what the problem is. So declaration expected, not if. So if direction equals FOV east. So this is... Oops. Mixing... So if I just copy this, right, and comment this out, and I go like this, what's the problem? And I have to get rid of this, okay? What's the problem? Why is this taking forever? What's going on? Coffee just splashed in my eye. That was real smooth. Okay, that built. Okay, I need a paper towel. What's the problem? Declaration expected, not if. It should just be expanding to this. This beam direction, right? Declaration expected, not if. I really... Because it should just be replacing it in place. And this compiles. So what the hell's the problem? Declaration expected, not if. I don't know what the hell that means. Why are you expecting a declaration? Direction FOV. $329. Yeah, okay. Okay, let me look up the documentation for mix-in templates to see if I'm not getting something completely wrong here. Template mix-ins. I think I might be using mix-ins wrong. So, if I instead say this, right? And then I get rid of this, and I come down here, and I do that. Huh? It's just a function call. Oh, right. Right. Like that? Right. We're just gonna have to come up here and get rid of these. Just say, hate that spacing. Hate it, I hate it, I hate it. Okay. Now does that work? No DC. Gonna call no GC. Ah, I forgot to mark this function. There. Ah, and I have to change the function pointers as well. Okay, that compiles. Awesome. Cool beans. I was simply using mix-ins incorrectly. So let's go through and fix these. Yep. Okay, let's see if that compiles. Error 386. 386. Variable D cannot be read at compile time. When, oh, right, I forgot. Yeah. This. Boom, boom, boom. All right. Hey, look at that. I think we've just translated the entire file. I mean, it only took me an hour and a half, but, you know, is what it is. All right, I need to stop drinking coffee. It's too late in the afternoon. There. Grab my water. Okay, so close this. Close this. This. Don't need this. Don't need this. Okay, so I think that's everything. So did I copy the settings functions? I did not. I need those. Do I need those? Do I really? These are just like getter setter functions, and I frickin' hate those. Yeah, these can go. I don't need those. Yeah. Okay. I think that's everything. Okay, so now let's try to actually frickin' use this in the code. Shall we? Okay. So actually, to get, I'm going to commit this. Oh, I never committed the bounding box stuff. Whoops. Whoopsie doodle. Let's do that now. Okay. So we can get rid of this. Actually, whoops, I think I committed that. I don't want to... Yeah. So I'm just going to add that to the get ignore, actually. Yeah. Okay. So where are we calling the FOV code? It's this function we're calling. Where are we calling it? Here. So we're going over all the entities, and this needs to be moved on here. She's so cute. Yeah, I'm talking about you. You're so cute, dog. Anyway, how are we gonna do this? Come up here and say import lib FOV. Whoops. Come back down to here, and we're gonna say FOV circle. close this for now. Okay. So we need an FOV settings. You know what? I'm going to rename this because I can. It should be FOV settings. Place. Oh, this FOV settings struct needs to be public. Just place it there. So we are going to need a new... This isn't ideal, but let's just get this working. Settings. FOV underscore settings. We're going to pass that. So on the settings, we need a is blocked callback. So that's going to be of this signature. So the settings FOV settings dot opaque is going to be equal to a function pointer. Now we need a function. Like this. So instead of this, we're going to have a void pointer. It's going to be our map data. So we need to... This needs to be here, and we need to take the pointer to that function, and then we need a apply. So that's going to be this. It's only going to Okay, so I think I just do this, and then I move this up here, and I change the function signature to be is there any documentation on this? So back over here. Oops. So apply, right? So by default, we want to Okay, so I have audio back. Why is the camera not updating? Yes, add video capture. That one. Okay. Freaking OBS, man. I swear. Filters. Add. Noise suppression. Okay. Jeez, oh Pete's. Okay, there it goes. So, anyway, after all that, okay. Anyways. Okay. Anyways. So, how is the stream looking? Do we actually have audio? Yes. Okay. Anyways, I was trying to figure out what the hell these parameters are. Here. Source. What is that? Map. Source. What is the source pointer? What is it? No, you gotta tell me this, man. Is that supposed to be like the pointer to... Is there any documentation in the header file? Is this actually used anywhere in the code? No. Okay, good. Okay. Not yet implemented. It's fine. Pass the test function. Okay. Parameter settings. Circle. Okay, what is this source? Pointer to the data structure holding the source of light. Okay, so this is just user data. Okay, so I'm gonna just grab this. So now when I hover over this, I get all that. Okay, cool. Oh, okay. So we actually need this function. Now replace all the arrow notation with dot notation, and replace all of this, D's version, and we want to say is, and then is. Okay, that looks good. Uint. Okay, let's see if that compiles. FOV settings type. FOV settings. There. Unsigned 112. Uint. Okay. Okay. Cool. Alright, so that compiles. You need to copy over the documentation for that. Okay. Okay. So we actually need to call this here. Okay. So a couple things. So number one, so this is fine. This is one of the problems with this API design. It should not assume that this void pointer is the map. It should just be a user data parameter. So where am I? Yeah, okay, so back here. I think I'm going to add another void pointer to the settings. So right now we got map, and that's... void pointer user data, right? And this is going to be user data is going to be a generic pointer to any data you want, useful for passing around context. Okay. And then here, user data. And we're going to go to here, user data. Okay. And then when we call this, we want to say void pointer user data. And then, so this is the opaque. Opaque. Okay, so data dot user data. And then we want to do the same thing with our apply function. So wait, so first of all, void pointer user data. Same thing here. So we're going to, this is on apply data by map data dot user data. Okay. So now what we can do is when we call FOV circle, so let's see. FOV circle, you need the settings. So I'm just going to copy this. Need a map pointer. So past void pointer game state dot game map address source. This is just going to be the entity. Actually, you know what? I'm just going to make this a null pointer because I don't really care. And then this user data pointer, I'm going to pass void pointer game state. So address, and then source X is going to be tile position X, Y. Okay. So it was tile position X, Y. We need apply. Then we need visibility callback. And then we need this right here. DXDY. I'm still unclear on what DXDY and XY are. So back in code here. Apply settings. Do we have any documentation on this? Apply. No. That would be down over here, I suppose. Apply. Wait, what's the difference between opaque apply and a... Oh, that's like the... That's a little confusing naming. Okay, so here's source X, source Y. So this is the... So XY. And this is the offset from... Oh, so this is how far away it is. Oh, why didn't you just say so, man? I mean, like... let's just add a note. Let's make these public. Params. So, amp equals from the initial FOV circle call, and then we'll say user data and we'll say X is the look to mark as lit. Then we'll do that for Y as well. And then dx dy, dx dy, location, distance from the source. Okay, and then distance from the source, and then source is going to be holding the source of light from the initial FOV circle call. Okay, generic pointer. Okay. Okay. I think that's all set up. So I'm just going to take this and paste it here. We don't need these. I don't think we need that either. So we do need to take the user data, and we need to say game pointer current state is equal to user data past game pointer. Okay. So let's see if this compiles. Function pointer cannot pass arguments and 307. Ah, I missed one. Source X. It's not defined. Right. Radius. What was the radius? Is this copy changed line? Do that, and then leave its target position. So that would be target position dot x, tile position dot x, and tile position dot y. Undeclared identifier current state. Line 395. Okay, so here. So we just need to do this same thing. Undeclared identifier visibility 433. So I don't think we need this anymore. Current target tile position. Interesting. So in this source pointer, actually, we need to store passing a pointer to stack data. It's dangerous. I never like doing it, ever. But I think we're going to have to. So this is pretty sure, so 1, 2, 3. Yeah, okay, so that's the source pointer. So I'm going to do cast void pointer to pointer to so current AI. So we need a entity pointer. No. Entity pointer. Entity. Oh gosh. We're going to be doing so many calls to the frickin'... For every single tile. So many calls to the entity manager for every single tile. What can we do? What can we do? What can we do? You know, we can pack in a whole bunch of data in this user data function, right? So instead of just making it a pointer to the game state, we can make a structure, which is like struct FOV context, and we can say like game state, current state, right? And then we can say like we can just do this, right? We can, right? Yeah. I like that. I like that a whole lot. So, we are going to build hey dog. We're going to build this FOV context. So FOV context, and we're going to say context dot current state is equal to pointer to the game state, and then we're going to say context dot current AI as a where's AI data, and then context dot tile position. Do that, and then there's one more field. What is it? Current state, current entity. Okay. So instead of that, no, so this is going to be, wait, so that's fine. We're just going to do that, right? And so when we come up to here and we say, we're going to say context, FOV context, cast FOV context, and then context dot current state, and then we can just do right. Right. We just need to do assert user data is not null, and then we just want to say context dot current AI isn't null, and then context current state isn't null. Okay. And we want to do the same thing up here. context dot, and then context. Okay, does that compile? It is not. 408. Oops. Bum. 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 Okay. Undeclared identifier current state 444. Context.current state, and then entity 457. Right. 444. Yep. 458. That looks good. Current entity 488. We don't need this. We don't need this anymore. Where's that? We can actually move these into here, right? Oh no. We cannot. Okay. 41. Don't need that. Current touch 491. Deck UI. Current AI. Okay. Oh, did I already copy that? Nope. Whoops. No G settings free. Oh. Okay. Okay. Link your errors are like my favorite thing on the planet. Like, right after a root canal. Okay, so unresolved FOV circle settings. FOV settings. Is there like a demangle call that I can do? So this copy. I want you to write out what the hell that is. And why aren't you copying it? Edit. Okay. Paste. Run. No GC, no throw. Lib FOV circle. So undeclared identifier. FOV circle. Referenced. For some reason. this is not getting output to the object file. Okay, so let's go to the build output. Honestly, you know what? You know what I'm gonna do? I'm just gonna clean house. Actually, so now what? Bro, 24 megabytes? Whatever. Can't worry about that right now. Is the camera still tracking? Yeah, okay. Because I've never fixed the bug where we're not automatically including the frickin' lib files and sending them to MSVC. That's why. I'm glad I didn't spend too much time on that. Okay. So now, let's do a review, because that was a buttload of code that we have now included as a critical component in our game. Okay, so we're coming down and we're saying we know the target position. The AI knows the position of its target. No. Yeah, okay. So, and then we're translating that to a tile position. And then we're saying, okay, we're going to build this context, right? And then we're passing in the function pointers. And then we're calling the FOV function, right? And we're giving it all these pointers and everything in the tile position. And then we're saying the radius. And then we're freeing that when we're done. So I'm actually going to just do a cleanup thing here. I'm just going to scope, exit. Okay. All right, we're doing all these sorts of things, right? And then up in the does light pass through function, right? We're coming here and we're saying, all right, we need the user data, right? And so we got this context, we're casting it back to the context because down here, we're passing the user data, it's the context pointer, right? And so that lines up. So it's settings map source user data. So settings map source user data. Okay. Honestly, right now I'm just gonna pass this as null. Okay. And then so we got this context, right? And then we're saying the current game state. And then we're calling tile blocked, and then we're saying yeah, okay, that makes sense. So we got the context here as well. This is marking. You know what? I'm just going to rename this. I'm going to say set tile visible, right? So that's a better name. Okay, so we're doing the same checking. And then we're saying if we're doing this debug stuff, okay. Yep. Okay. This all looks good. All right. I have no idea what's going to happen when I actually run this. Right? All right, so over here, let's go in the entity code, and let's put some breakpoints on these functions, right? And then let's run the game. So immediately, oh yeah, because the entity runs first. Okay, so we're gonna step. So delete these. So we want to look at this context pointer. Hmm. I might have screwed up the truthiness and falsiness. So, so opaque, if opaque. Yeah, so we're saying is opaque. And then back here, we need to double check that our code is saying is opaque. So we're turning, we need to return true when it's blocking, right? So we need to come down here and say, bam. So we're going to rename this is does block site. There. Okay. Okay. Let's rerun this. Okay. That looks good. Run. So bum 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 bum. I guess just because there's no source code available, that's just, this isn't possible to step through. Okay, well, let's step out. I don't want to look at the assembly code right now. Okay, this seems to be calling it correctly. Alright. So, moment of truth, I suppose. Okay, so because the door is there, they can see through the door, right? I suppose so. Let's do a test, right? Let's replace this with a wall. And they can't see through it at all, which is awesome. How are we doing on performance? I'm not seeing any massive frame spikes. Not any more than usual, anyway. So let's also, let's go into the entity. Let's increase the bounding box here a little bit. Save. So they're completely unable to see through. So let me, one more thing. Let's go back to the tile and let's get rid of the walls here. So that looks great, actually. I'm actually really happy with this. I can't believe that that was that simple. I would have totally expected a bug or two from the conversion process, but it seems to have gone off completely without a hitch. Okay, so let's fix the changes that we did. So we want this to be smaller. Save. We want to put the door back. So let's do that. Door, save. Save. Okay, so let's play the game like normally. So turn off the FOV stuff. Oh wait, FOV. Okay. So push this boulder out of the way. And it used to be, if I stood right here, they would see me. And now that is not happening. Awesome. And because this diagonal stuff. So kill this guy. Kill this guy. So that's the same bug we noticed earlier. Dead. Okay. Awesome. I'm actually really, really happy about how all that went. Okay. So let's do some cleanup. So first of all, because we have a working state, let's commit this. Finish translation and implementation of libfov in the entity code. Yeah. Origin. Alright, let's do some cleanup. So we don't need, if we have this user data pointer, we don't need these, honestly. It's just unnecessary. And then down here in the call, we just need this context, right? So let's in here, just user data. User data. Yeah, don't need these. Don't need this. We don't need this. We don't need this. Remove these from the parameter list. Don't need this. So just to double check that we got everything. Nope. So source and map. Don't need that. Source and map need to go. Okay. Whoops. Okay. All looks to be working. Working as expected. Okay, that all looks good. Okay, anything else we can do to make this a little bit more understandable and readable? So let's take, I'm actually just going to grab these. And I'm going to make them private to this. Move them down here. Gonna come back up here. Entities. Okay. So, one of the things I don't like is we're allocating a whole bunch of memory. Right? And then we're freeing it for every single entity. I really don't like that. And also, it's using malloc and free, and we want to give the user the choice of which allocator they want to use. Move. Can move this in here, right? Okay. So in here, so I'm going to go back to the build script, right? And I am going to change it so that libFOV depends upon our standard library replacement that we got. And then I'm going to come over to... You know what? We're just going to delete this. Just see ya. So where were we importing that? Entity 39. Shoot. Awesome. Why is it taking so long? What's going on, Microsoft? What's going on? Microsoft. There it goes. Holy crap. Is that repeatable? No. Okay, that was just a weird one-off error for some reason. Okay. Okay, so back over here. We want to... So we have this array of arrays, right? So we got this multi-dimensional array. Oh gosh. You know what? I'm going to leave that for now. We will come back to that later. So we're going to put it up in our to-do. We're going to say, first of all, so we are going to say, modify the libFOV code so that it can use the allocator design. Make it use the per frame arena. Okay, so that's going to be an optimization that we're going to do later. For now, so I'm just going to say some clean up. Okay, cool. And then the last thing I want to do today is I want to add a debugging command to the in-game console. I want it to be a no clip command. Toggle no clip, right? So we want to come down here. I'm gonna have a new command. This is toggle no clip. We want to add a new debug flag on the game state. And then boom, boom. Okay. And then over in the player input code, so we're gonna search for is tile locked. So this blocks. I think all we need to do is just game state dot debug player no clip enabled false. Whoops, didn't mean to do a full rebuild. Okay. So if we come in here and I come over here, I can't move through the walls or anything as expected, but if I do TCL, I guess it's using the A star. Ah, yeah, so in the A star code. Right. So we can special case it for now. We can just say we have the entity. I mean, we can just say check oh, screw it. Just no clip equals false, right? And we can just come down here. And this is where we're checking it. So if so mutable doesn't block is equal to it, but we're gonna say no clip, right? True. Like that. It doesn't block. We're gonna come back up here to A star, and we're gonna find where we're calling this. A star. Okay. And then the final, yeah, bailout 5 to 12, that's fine. And then no clip, game state dot debug no clip enabled. All right. Undeclared identifier no clip. Oh, I forgot the type. Whoopsie. Bum 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 bum. And why are we checking for collision in the... Yeah, why? We should not be checking for collision in this code. Yeah, that's not the responsibility of this code. Okay. Oh, whoops. Run. Okay, no clip. And look at that. Right through the walls. This will be very helpful for debugging. Okay. Awesome. And honestly, when I'm no clipping, I kind of want to make it so that I move really fast. So is there a, where's the movement? Movement. So we're in our config file. Go to location movement DT. Here we are. Times delta time. What I'm gonna do is, let's say, if data.entity is equal to player ID. And you know what? Actually, just always game state debug player no clip enabled bt times 2. Screw it. Boom. Every time. Okay. Okay, so turn on no clipping, and then I should move really fast. Hey, that's really helpful. Because it's just going to speed up debugging so much. Okay, awesome. Okay, git add all commit added no clip debug command. Okay, I think that's literally everything I wanted to do today. Okay, that's it. I am done for today. Stream's done.